All right, energy is the ability to do work. So if anything has energy in it, that means that work can be performed. Remember that energy also is taken in units of joules. And this should be familiar to you because work is also taken in energies in units of joules as well, just like energy is. Later, we'll see how work and energy can be combined in the work energy theorem and see the relationship between kinetic energy and work. Inside this class, we're going to talk about two main types of energy, and that's going to be kinetic energy and the other one is potential energy. Kinetic energy is energy of motion. That means anything that's moving has kinetic energy. That can be atoms, it can be a car, it can be a rocket, it could be this planet, which is a large body moving through space. Potential energy is what we call stored energy. And there's a lot of different types of potential energy as well. We have elastic potential energy, we have gravitational potential energy, we have chemical potential energy, we have nuclear potential energy. So that's energy that's stored up. The good way to think about potential energy is think about like gasoline. We know that gasoline has energy inside of it, but you won't see that by just looking at a tank of gasoline. In order to see that energy, you must add a flame to it and see the combustion process and see the gas explode. If we see that take place, then you'll say it has a lot of energy in it. But understand that gasoline still has that energy inside of it as potential prior to it actually exploding. So potential energy is energy that's stored up, and that's where we get that definition from. Both of these two types of energy have equations to them. Kinetic energy inside of this class has an equation that says kinetic energy equals mass times velocity squared divided by 2. In this case, we're concerned about two things: the mass, how heavy the object is, or how much matter makes it up, and the velocity, how fast the object is moving. So we're concerned about those two objects. If it has mass and it has velocity, the larger it is, the faster it's moving, the more kinetic energy the object has. Mathematically, in order to solve for this, what I would do is take whatever velocity they gave me, square it, then multiply times my mass, and then take that answer and divide it by 2. And that will give me my kinetic energy. But on top of that, you must be able to manipulate this equation and solve for mass and also solve for velocity. So to solve for mass, I will take the same equation, multiply each side by 2. That cancels this over here. So now I have 2 times Ke equals mv squared. And now, since I'm solving for mass, I'm going to divide by v squared from both sides. Cancel that out. So that means that mass equals 2 times Ke divided by v squared. And then finally, be able to solve for this guy, v squared. I'm going to take my original equation to do this so you can see it. Ke equals mv squared divided by 2. Same thing, I'm going to start by multiplying each side by 2. Cancel that out. So now I'm going to have 2 Ke equals mv squared. I'm going to divide by m to get rid of the mass. Now I have 2 Ke over m equals v squared. And now to get rid of the square, I'm going to take the square root of each side. So that means that v equals the square root of 2Ke over m. So that equation we'll put up here. which V equals the square root of 2 KE over M. With this, I can ask you as a teacher to solve for mass, the velocity, or the kinetic energy. And that's important that you have that skill in order to do that. The next video, I'm going to discuss potential energy, how to solve for it, and then look into kinetic energy.